This particular problem gives us information in regards to the radius r of a sphere is increasing at a uniform rate of 0.3 inches per second. So the radius of the sphere is increasing. And what we're trying to find here is the want step. So when you when you get information about a rate of change of something, you're going to put that in your know step. Okay, and then when you see what the question is, in this case it says, what is the rate of increase in the volume? So we're trying to figure out the rate of increase in the volume, which is the rate of change of the volume, at the precise moment when the surface area is fixed at 100 pi square inches. Okay, that being said, we're also given these two equations here for surface area and volume. So if we want volume, in other words, we want the dV/dt, the rate of change of the volume, then we're going to need to get a rate of change of the volume in an equation. And so it kind of begs us to take this equation here and differentiate both sides. So we're going to differentiate both sides with respect to t. Okay. And we know from our implicit differentiation section that the derivative of this function of r with respect to a different variable, we have to use the chain rule. Okay, and so the left side remains what we want it to remain, and that's our dV/dt. So all we have to do now is just simplify the right side and put something in that we'll deal with that later. But the derivative of the right side then would be 3, using the power rule, multiplied by the 4/3 pi times the r squared, but then multiplied by the dr dt. These related rates problems always have plenty of safety nets. Safety net number 1 is when you write down what you want over here, that kind of tells you what to do. If you want a dV/dt and you don't have a dV/dt but you have a v, then you just ddt it. Alright? And then if you know, here's another safety net. If you're given dr dt, and then when you take the derivative of v with respect to t, when you get the right side, if you don't get a dr dt in your equation, your new equation, then that's a reminder that you need a dr dt in there to really use the chain rule here. And so that is again another safety net, because sometimes students forget the dr dt, and when you forget the dr dt and you see a dr dt, you go, oh yeah, I've got to have a dr dt in there. I'm going to try not to say dr dt anymore in this problem here. Getting tired of saying it. Well, anyway, what we want is the dV/dt at the precise moment when the surface area is 400. Now check this out. This is kind of cool, and this is how many of these AP questions go. They don't go like that. Let me pause. Alright, I'm not sure where we were here, but I can kind of see where we were. I think I was saying something along the lines of, this is how AP questions go. You've got this something that kind of falls right in your lap. If you see it, we want dV/dt at the precise moment when the surface area, which is this thing right here, has a value of 100 pi. So we're just going to replace this 4 pi r squared with 100 pi. Okay. And then the constant 0.3, there's our answer. And so we look at, what's 0.3 times 100? Well, just be careful with this kind of a thing. If I'm doing this problem, what I'm going to do here is I'm going to rewrite that as 3/10. This is where students will make a mistake. It's kind of interesting. You've got your calculus, and then you've got your multiplying decimals by whole numbers, and the multiplying decimals by whole numbers is where students are going to make the most mistakes. So let me think this through here. I have 3/10. 10 goes into 100 10 times. We have 10 times pi times 3, and so we end up with 10 times 3 is 30 times pi. Okay, so 30 pi, and where's that answer? That would be E. Okay. I saw many of you who have already submitted your answers online have submitted an E for that, so nice job. That's a really nice job, because that's not really an easy question. It's more like it doesn't fit exactly how we've done each of the problems in terms of you're usually given something else. You're not usually given another variable here that you have to plug in. So nice job if you got that.